is me, Christine Morrison, born in 1964. I no longer live in South Shields, I'm back in Newcastle. I was born in Hollyhill Gardens, South Stanley, County Durham, the eldest of 5 children. My mum, Maureen Lawler, was her maiden name. My dad, Edwin Morrison. And I don't know my dad's name, but his mum's name, my nana, was Lavinia Gertrude Nelson before she married and became a Morrison. Okay, so 2020, got my kids to get me a DNA test because after COVID in 2020, I had a spiritual awakening that guided me to Reiki, guided me to pendulum use, and I received a lot of messages which were taking me back in time, explaining my guides basically. But they would take me to places like Egypt and stuff like that, and I'm like, what's it got to do with me? My 23&Me, when it came in, later, actually told me I was 99 point, whatever it was, but sorry, British Irish. But when you get your DNA done with one side, there's quite a few other sites you can upload it on. So this is where I ended up getting further information. Okay, so my birthplace was the Hollyhill Gardens, South Stanley, County Durham, in the United Kingdom. I don't know where my parents or grandparents were born. The family surnames I do know is my father's side, Morrison. Nelson was his mother's maiden name. Murray was my mum's maiden name. And she married Terence Lawler or Ted Lawler and became Lawler, and then my mum was Lawler. So the family surnames, Morrison is my father, Edwin Morrison. His mother was Lavinia Gertrude Nelson. Murray was my nana, Mary. She was my mother's mother, Maureen Lawler, who married Morrison. My ancestry composition, compare your DNA, connects to populations around the world. And I got European 99.8%, and that shows as British Irish. Western Asian and North African, 1%, 0.1%, and that shows Arab, Egyptian, and Levantine, Peninsula Arab. And 1%, 0.1% unassigned. My maternal haplogroup, J1C3, I don't have a maternal haplogroup because I don't have my father's DNA. It shows your Neanderthal percentage, and I think mine's 1% or something. And it's the traits, but I'm not really interested in the traits. I was interested in, like, where I come from, what makes up me, with no expectations. Okay, you descend from a long line of female ancestors that can be traced back to Eastern Africa over 150,000 years ago. These are the people of your maternal line, and your maternal haplogroup sheds light on their story. And it gives me goosebumps when I think, like, it shows in your DNA and the chrome, and it's just amazing. Okay, so as our ancestors ventured out of Eastern Africa, they branched off in diverse groups that crossed and recrossed the globe over tens of thousands of years. Some of their migrations can be traced through haplogroups, families of lineages that descend from a common ancestor. Your maternal haplogroup can reveal the path followed by the women of your maternal line, and that's what interests me. Okay, so this is where we began. And every person living today, if every person living today could trace his or her maternal line back over thousands of generations, all of our lines would meet at a single woman who lived in Eastern Africa between 150,000 and 200,000 years ago. Though she was one of perhaps thousands of women alive at the time, only the diverse branches of her haplogroup have survived to today. The story of your maternal line begins with her. Sorry. 65,000 years ago, your, it's because I haven't got a mouse on. Your branch of L is haplogroup L3, which arose from a woman who likely lived in Eastern Africa between 60,000 and 70,000 years ago. While many of her descendants remained in Africa, one small group ventured east across the Red Sea, likely across the narrow Bab el-Mandeb into the tip of the Arabian Peninsula. And you see how my DNA showed Arabian Peninsula in there too. 59,000 years ago, your story continues with haplogroup N, one of two branches that arose from L3 in southwestern Asia. Researchers have long debated whether they arrived there via the Sinai Peninsula or made the hop across the Red Sea at the Bab el-Mandeb. Though their exact routes are disputed, there is no doubt that the women of haplogroup N migrated across all of Eurasia, giving rise to new branches from Portugal to Polynesia. One of those branches in haplogroup R is haplogroup R, which traces back to a woman who lived soon after the migration out of Africa. She likely lived in Southwest Asia, perhaps in the Arabian Peninsula, and her descendants lived and migrated alongside members of haplogroup N. Along the way, R gave rise to a number of branches that are major haplogroups in their own right. While some members of R travelled far and wide, some remained in the Middle East for tens of thousands of years. Haplogroup J arose among the latter group, the Middle East group, from a woman who lived approximately 35,000 years ago. When the climate warmed at the end of the Ice Age, approximately 12,500 years ago, some of her descendants gradually migrated throughout Europe to the west and to Central Asia to the east. Your maternal line stems from a branch of haplogroup J called J1C3. It is a relatively young branch of J that traces back to a woman who lived approximately 9,000 years ago. Her ancestors migrated into Europe from the Middle East as the Ice Age receded between 14,000 and 11,000 years ago. While J1C3 already existed in the West before the spread of agriculture, it likely expanded along the farming populations as they moved west across the continent. Today, J1C3 is found almost exclusively within Europe, and researchers speculate that the traces of J1C3 in the Middle East are due to eastward migrations of people much later in human history. Today, you share haplogroup with all the maternal line descendants of the common ancestor of J1C3, including other 23&Me customers. 1 in 100 of 23&Me customers share the same haplogroup as myself. And you had royal blood. You and King Richard III are descendants of a European woman who lived around 13,000 years ago. The much maligned English monarch King Richard III died in the Battle of Bosworth Field in 1485, likely the result of a severe blow to the back of his head. Richard's body was buried in a friary church in Leicester, but the structure was demolished less than 100 years later, thanks to the dissolution of the Catholic Church in England, and many thought his skeleton lost to time. In 2012, a team of researchers decided to launch a hunt for the monarch's remains. On the first day of excavations, archaeologists uncovered a human skeleton with signs of scoliosis and severe head wounds, which matched descriptions of the English king. To confirm his identity, scientists tested the skeleton's mitochondrial DNA and found an exact match with a documented maternal line descendant of Richard's sister, Anne of York. In early 2013, the University of Leicester announced that the skeleton undoubtedly belonged to Richard. And, we're related. It's however minutely, we have a common ancestor. Wow. The genetics of maternal haplogroups. Maternal haplogroups are determined by sets of genetic variants in a tiny, unusual loop of DNA called mitochondrial DNA. As the name suggests, mtDNA is found in the mitochondria, small but mighty structures inside our cells that turn fuel from food we eat to energy. Mitochondria evolved over billions of years from an independent bacterial cell that was engulfed by another cell. Instead of becoming lunch, the bacterium helped its new host use oxygen to produce energy. Over time, it completely lost its independence and became an integrated part of the larger cell. Maternal inheritance. mtDNA is a powerful tool for tracing the history of maternal lines because of the way it's inherited. Everyone has mtDNA, but only females pass it down to their children. So, for example, an individual inherits a copy of their mother's mtDNA, who inherited it from their mother, who inherited it from theirs, and so on through the generations, along an unbroken line of female ancestors. The copies passed down are not always perfectly identical, however. Small typos in the mtDNA sequence occasionally occur, creating new genetic variants. Over many generations, these variants stack up in a unique pattern that are carried by different maternal lines around the world. Only mothers pass their mtDNA down to their children. By comparing the mtDNA patterns from around the world, researchers identify families of maternal lines. All the lines within each family trace back to a single common ancestor and share a set of mtDNA variants that they inherited from her. In fact, when we look at very far back in time, all the maternal lines around the world trace back to one woman. Along with her ancestors, she forms the root of a great tree that shows how all maternal lines are related. Each subfamily in this tree is called a haplogroup and named with a sequence of letters and numbers that reflect its location in the tree. That's my line in the tree, 150,000 years ago. And oh no, sorry, she's the beginning, the first woman. So it's split off there. That must be the Asian and the European. Yeah, that was the Asian, that was the European then. And there's me in here. It's just so interesting. Tracing female migrations. Next, geneticists study the relationships between haplogroups and compare them with the distribution of each group around the world. Because closely related haplogroups tend to share geographic roots, researchers can play a sophisticated version of connect the dots to estimate the origins and migration patterns of particular haplogroups. Finally, combining this genetic evidence with data from other fields of study helps researchers place the story of each maternal line within the broader context of human history. Each haplogroup is defined by a set of mtDNA variants that were inherited from a common ancestor. Wow. So, yeah. So, scientific details, I don't know what that is. I haven't even looked at it. I don't notice these bits at the top. Oh, right, it's just going into the technicalities of how I got from L to the G to the G1 to the G1 C3. And it's got all the subclubes in there. Okay, so if we go to, so that kind of gives you information, but then I uploaded it onto Genomelink, and Genomelink looks at your ancient ancestry and they look at your DNA at a chromosome level, so you get so much more information. So this is the breakdown when I've uploaded the raw data to Genomelink. Northwestern European 59.6%, and Northwestern Europe is British, French, German, Irish, Scandinavian. Other European, 14.7%. And that other European is Spain, Italy, Czech Republic, Hungary, Croatia, Slovenia, Greece, Bulgaria, Albania. East European, 19%. Estonia, Finnish, Russian, Ukraine, Polish. Asian, 1.5%. Mainland and Maritime, East Asia, Southeast Asia, Dravidian, West Asia, Near East. Native Peoples of America, 0.4%. That's North and Central America, the Amazon, Caribbean, Andes, and Patagonia. It's got 0 and 0 for these, but you'll see that Africans, it's not correct there when you look at the other information. Other, 4.8%, is the Arctic and the Near East. So on this one, it tells you a little bit more. I don't have premium, so I can't get all of the information. But let's see what I can show you. What it will show, actually, let's just do it. It will show you a sample report. So here's a sample report of my global ancestry. When it decides to open. Okay. So it only gives like tiny fractions, but when each different section gives you like different fractions, so you can piece the bits together, the bits that are missing. So the most frequent ethnicity on my overall ethnicities here, my global ancestry is 18. Most frequent ethnicity is Balkan at 24%. The most unique ethnicity is Scandinavian at 1%. You see how the Africa is shown up here? I'm actually we're everywhere. So Balkan 24%, West African 21%, Native Peoples of Andes 12%, Native Peoples of Amazon and Caribbean 10%, Maritime East Asia 9%, Maritime Mainland East Asia 6%, West Asian 4%, and I have wrote the rest down in a little journal here, so I'll tell you. I think. Oh no, that's gone straight to me. No, I'm just going to leave that at the end because it's gone straight to me breakdown. So by chromosome, they're giving you obviously just little bits of samples. So this is chromosome 22. So on chromosome 22, I have 10 ethnicities. Arctic, 31%, Dravidian, 13%, Native Peoples of the Andes, 12%, and there's 7 more that they're not showing. But through the exploration of reading the others, I've got, oh no, that's chromosome 1, sorry, just ignore me. Chromosome 22 was about the same size as chromosome 21 at 40 million base pairs. However, chromosome 22 carries almost twice the number of genes. Of these 800 plus genes, there are quite a few that are related to genetic disorders. For example, DiGeorge syndrome is caused by a deletion event on chromosome 22 and leads to congenital heart problems, cleft palate, and developmental delays. So going into a little bit of details, it's showing the native peoples of the Andes up here on 2% and down here at 10%, 2 segments. And here it's showing you 31% Arctic, 13 Dravidian, 12 native peoples of Andes, 10 Amazon and Caribbean, 9 Maritime, 6 mainland East Asia. Most frequent Arctic, 31%. I hate the cold. So that's breaking it down there. And then it's shown here. Arctic shared with 6 chromosomes, Dravidian with 5, native peoples of the Andes with 1 chromosome, native peoples of the Amazon and Caribbean shared with 6 chromosomes. Deep dive into ethnicities, rich dynamic content for each ethnicity, 20% total Dravidian on 5 chromosomes. So let's read about Dravidian. 4,200 years ago, there was a massive climatic shock across Eurasia. Drought spread across the land. This event resulted in the fall of the Old Kingdom of Egypt, the overthrow of the Mesopotamian dynasty of Sargon of Akkad, and perhaps the first steps in the collapse of the cities of the Indus Valley civilization. For the two former civilizations, we have text documents. For the third, we have archaeology. I can't speak archaeology. We do not know what they called themselves, though the Mesopotamians seem to have called them the Meluans. Their civilization included most of modern Pakistan and parts of the north and west of India, and was anchored by two great cities, Mohenjo-Daro and Harappa. After 2000 BC, civilization went into decline. The cities disappeared, humans devolved to small-scale villages. We do not know what language these people spoke, but we know something of their genes. Their ancestors had occupied the eastern edge of the Iranian plateau and developed farming independently, though perhaps with some inspiration from their cousins to the west. They expanded eastward into the basin of the Indus River. Over 5,000 years ago, they mixed with hunter-gatherers, moving north and west. People distantly related to the indigenous people of Southeast Asia. The resultant people were a synthesis of West and East, though perhaps with more Western heritage. Today, this ancestral component is the largest fraction in India. It is most prominent in Dravidian-speaking groups of the south, who seem to have arisen through the mixture of people who migrated from the society and indigenous hunter-gatherer groups. While the north of the subcontinent has been washed over by outsiders, Aryans, Huns, and Turks, the south has been insulated from war, though exposed to trade. Roman colonies and Roman coins were numerous along the southern coast, and shielded from the shock of Islamic invasions, great temples arose at the southern tip of the continent. More than 20 ethnicities. Native peoples of North America, 6 chromosomes. Iberian, 18. Italian, 6. Southeast Asia, 6. It's not shown as a percentage, though, see. Balkan, 18. Northwest Europe, 18. Mainland East Asia, 18.